For lesson 5, part 2, we are going to be composing our functions. I'm awesome at life here. We did some operations with functions last time. Now we're going to be putting functions inside of functions. And we kind of snuck a couple of those into the last of examples where we put an x into, like a 2x or an x plus 2 into another function. That's the same idea that we are going to be executing here with compositions, except we're going to be naming the other function. And so the idea is that if we compose a function, we're going to write this notation. G of f of x means g of f of x, meaning we're going to put f of x, whatever that function is, we're going to put that in place of the variable in function g. All right? So the domain of this function is going to consist of the domain from f that also works in g. So it gets a little complicated. Really what I'm concerned about today is making sure that we can evaluate this function, take that output, put it into this function if we are assigning a value to it. Otherwise, if we're doing an expression, like let's pretend f of x is x plus 1, we're going to put x plus 1 in place of the x's in g. If I know that x is equal to 3, then I'm going to put 3 into f, and I'm going to take that output and I'm going to put 3 into, the output from f of 3, and I'm going to put that into g. So it is a little bit, there's a lot happening there. We want to make sure that we do a quality job with this information. And then we'll wrestle with how does this affect the domain of our new composed function, all right? Because we'll be doing inverses with these functions and these compositions, and so it'll be a little exciting to do. So here is f of x, and there is g of x. If I want to find g of f of x, it means I'm doing g of f of x. And maybe it will be helpful for me to color code so that f of x is red, all right? Essentially what we're going to be doing is substituting x minus 2, which is f of x, in place of the variables in g. And we've already done some of this. And so this is going to give us this expression, which is going to be x squared plus 3x's minus 2, but in place of the x's, we're going to have this expression f of x. Another way to write that is to say that this is the same as having f squared plus 3f's minus 2. So two ways to write that, but really we want to be able to execute these operations. So I have to do x minus 2 squared, which is going to give us x squared minus 4x plus 4, and then we're going to be adding 3x minus 2, so there's 3 x's and negative 6, and then minus 2. All right? So now we get to combine our like terms. We've got our x squareds, we've got our x's, we've got our constants. And when we combine all those terms, we have our new g of f of x is x squared minus x minus 4. Find f of g of x. Here, when we say f of g of x, what we're saying is, what if we put g into f, meaning that instead of having x minus 2, we would have g minus 2. So really all that we have there is x, which is x squared plus 3x minus 2, and then we are subtracting 2 more. Sorry for the handwriting there, that's a minus 2. So this actually gives us x squared plus 3x minus 4. This is the composed function f of g of x. Now, other times we'll be asked to compose a function into itself, but here it says g of negative 5. And so there's kind of a couple ways that we can approach this. One way is to do g of x and then evaluate with x equals negative 5. The other way to do this is to say that we do g of negative 5. And so we substitute negative 5 into g, and then we take that output and we put it back into g of x again. All right, so a little bit interesting, but whatever. Let's kind of see how this shakes out. If we do g of x, this is going to get a little bit messy because we would have g squared plus 3g minus 2. And squaring this is going to get a little bit messy, right? We get x to the 4th, we get 3x cubed minus 2x squareds plus, let's see, I did this times each of these. Now I got to do this times each of these. Now I'm going to get 3x cubed again. I'm going to get 3x times 3x, which is going to be 9x squareds, and 3x times negative 2, negative 6x and then negative 2 times each of these. I'm going to get negative 2x squared, negative 6x's, and a positive 4. And so when I do all of that, I get this kind of big, long polynomial equation. It's plus 5x squared minus 12x's plus 4. But then now I need to evaluate that for x equals negative 5. So I do all of that work, and then I have to substitute negative 5 in here, negative 5 in here, negative 5 in here, negative 5 in here. So this might not, just judging by the style of question it might not be worth our while to do that. It might be easier for us, instead of squaring a quadratic, to get a quartic and then to evaluate the quartic for this value of x. What if we just substitute negative 5 in here? What if I put negative 5 in there and I get 25 minus 15 minus 2, and this gives us 8, right? That's going to give us, that equals 8. And then instead of doing all of this work, I'm going to now plug 8 in here, and I get 8 squared plus 3 times 8 minus 2. And so this is going to give me 86. That work is maybe a little bit easier. We can kind of mental math that instead of doing out all of this algebra. Now that might depend on what the expression is. If we're doing f of x, that might be fine to just plow through and do that work. If it's g of g of x, we're going to be putting a quadratic into here. Oh, by the way, and this was just, I just squared it. I didn't even do the rest of it. The rest of it, I'd still have to add my 3 g's, my 3x squareds plus 9x's minus 6, and then I'd have to subtract 2. All right, so this is, there's even more to do here, and I don't want to do it. I'm sure that you can feel the same way. But obviously, if you want to see me map that out, I can do that. Just visit me during seminar, and we'll go through it that way. So this is compositions of functions, where we are putting a function into another function. Obviously, if we were evaluating, it might be easier to just evaluate it in stride, rather than plugging the function into the function and then computing. All right, over here, we have these functions for x. We've got f of x and we've got g of x. And for these, I have some where we are going to evaluate and some where we are going to just combine. So g of f of x means I'm going to be taking x squared plus 7, but in place of x, I'm going to be putting x cubed. So when I take a power to a power, that means I have x to the 6th plus 7. Not too bad, all right? Now, if I want to find g of f of 2, g of f of, of negative 2, I can do two things. One, I can put 2 in here, negative 2 in here, and then I can take that output and I can put it in there. So there's kind of two ways. Like I said, we can do x to the 6th plus 7 with x is equal to negative 2, or we can do g of f of negative 2. Negative 2 cubed is negative 8. I can do g of negative 8. G of negative 8 is going to be 64 plus 7, which is 73. I can add 71. Over here, we would have to take negative 2 to the 6th power and then add 7. This would give me positive 64 plus 7. Hey, you would end up with the same answer. So either of those approaches will work, and this is what I was trying to model on example C on the previous slide. Want to make sure that you can, of course, do g of f of x, or f of g of x, or f of x, or g of g of x, that you can do that algebra 1, and you can, all right? And then substitute in the number, or do we just substitute the number and roll, all right? You can try this. You're going to do this two ways. You're going to find f of g of x, and then substitute x equals 2, and then do f of g of 2. All right, you're going to do these two methods for f of g of 2. That's what I want for you to try to do. That's really is two things that you're doing. But I want to see what you are capable of, and it's important that you try those, because if you are doing it this way and it works, and you're doing it that way and it's not working, or this one works better than this one, at least you know. If you are not getting the same answer, you know that there's an error in there, and this can help us inform what misconceptions do you have? What things does Mr. Hibbett need to say differently or better so that you can understand it more clearly? Is there a gap in your understanding of how to substitute or to do compositions? And so that's what we want to get to the bottom of. That's why I ask you to try those. that is it. That's a kind of a short video. I hope that that worked out well for you. Please let me know what questions you have so you can perform these operations with functions, including compositions.